There, found it.
She's got a ticket to ride. She's got a ticket to ride. She's got a ticket to ride, but she don't care.
Dude, I'm such a dork. All right, hey, so that was the Beatles, Ticket to Ride. Let's say that's like 1960. Says it's 1962 to 1966, somewhere in that range. All right, and once again, I have probably totally broken copyright laws or something. So somebody can come and sue me. Exponents, the power rule. Let's take a look at some exponents here. The power rule. Here's my first one. X squared. What is it? X squared. The little square is telling me to write this out twice. So this is x times x. That's what an x squared is telling me to do. So when I square an x to the third square, isn't that telling me to write out x to the third twice? So isn't this x to the third times x to the square, x to the square, x squared. That's, see this square, it's telling me to write this out twice. But then what are the cubes telling me to do? They're telling me to write each of these x's out 3 times. So now I have x times x times x, that's this guy, times x times x times x, that's this guy. And what do I have? X to the 6th. X to the 6th. Look what happened. So it's x to the 6th. Do you see this guy right here? See those two numbers? What's 3 times 2? 6. When I'm raising a power to a power to a power, multiply the exponents. Power to a power, multiply the exponents. Here it is. This is a power being raised to a power. Multiply those exponents. This is m to the 12th. Because what's really happening here is m to the 6th times m to the 6th. And now what I'm looking at is a base add. So if I add them, I get m to the 12th. So there are lots of ways of working through these problems. Ready? This is a power to a power. Multiply the powers. That's c to the 10th. What people are going to do, they're going to get confused, and some people are going to try to add those. This is not a base add. It's a power to a power multiply. So we have two big rules. We have base add, or we have power multiply. This is c to the negative 10, excuse me. And express your answers using a single exponent. There we go. Power multiply. I'm going to multiply those two powers. It's going to give me t to the 30th. Negative 3 times negative 10 is a positive 30. I'm going to look at this one in two different ways. Could I write this out 3 times? Yes. So I could go d to the negative 4 times f squared times g to the 11th, d to the negative 4, whoa, I messed that up, times, I shouldn't have put a parenthesis there. Here, let's try this again. Okay, I'm going to write it out 3 times. D to the negative 4, f to the second, g to the 11th. D to the negative 4, f to the second, g to the 11th. D to the negative 4, f to the second, g to the 11th. So, base, 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 add those exponents. That's going to give me d to the negative 12. Base, 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 add those exponents. That's going to give me f to the 6th. Base, 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 add those exponents, g to the 33rd. So there's the answer. And I got that by expanding it out and adding up the exponents. The other way to do it, it's going to look like distribution. It's not distribution, but it looks like distribution. The idea is that I'm going to give that cube to all the other exponents. So this is d to the negative 4 times 3. That's going to be d to the negative 12. 3, this is f squared to the 3rd. That's going to give me f to the 6th. G to the 11 to the 3rd is going to give me g to the 33. I know it looks like distribution. It's not distribution. It just looks like it. Okay, that's it. See you later. Bye-bye.